covering today is 2.2, transformations of linear and absolute value functions. And of course I have to put a picture of Optimus Prime on here because he is the ultimate transformer. But first of all, we are going to take a little trip down memory lane, just to make sure that you guys remember a little bit about functions. Okay, so solve the following equation when x equals 3. I think you can handle this. So what I do is I just plug in 3 for x, right? And I get y equals 5. Mrs. Oldham, that's really easy. Why are you doing that? It's ridiculously easy. Well, how would we write this using function notation? Okay, we would do f of x equals x plus 2. Again, that's something that you've seen before for years. Okay, and then if we want x to equal 3, we just say, what is f of 3? So whatever is here gets substituted in for x here. Okay, so same thing, just written a little differently. We've got f of 3 equals 5. So instead of just y equals 5, we have f of 3 equals 5, which is nice. And again, we're just taking what's here and we're plugging that in for x. All right, so here's some examples. If f of x is x minus 2, then what is f of 2? Well, again, if this is 2, I put in 2 right here. So 2 minus 2 is 0. What is f of 4? Well, that's 4 minus 2 equals 2. What is f of 2x? Now we get a little bit more abstract. Whatever is here is going to get plugged in for this x right here. Okay? So f of 2x is 2x minus 2. Again, I'm just taking this x, taking it out, putting in 2x. What is f of x squared? Taking out the x, putting in x squared. This is when they get a little more complicated though. What is f of x minus 2? Take out the x, put in x minus 2 minus 2. And that gives me x minus 4. And then, what is f of x squared minus 3? Well, I take out that x again, and I'm going to put in x minus 3 minus 2. So that gives me x squared minus 5. Okay, so I just have a couple for you to try. I want you to try these with f of x equals x plus 3. So go ahead and pause right now. All right, so what is f of 2? Well, I plug 2 in for x and I get 2 plus 3 is 5. What is f of 4? Well, I plug in 4. 4 plus 3 is 7. f of 2x, I plug in 2x for x. I'm not multiplying or anything else. I'm just taking out this x, putting in 2x. So f of x squared is x squared plus 3. f of x minus 2, again, taking out x, putting in x minus 2, and then I have plus 3. So that gives me x plus 1. And then f of x squared minus 3, I've got x squared minus 3 plus 3 is just x squared. Okay? So I hope that was pretty easy because now we're going to use this to learn about our lesson today. So I don't know if you remember, and you don't have to write this down, but I don't know if you remember the transformations that we talked about last time. Okay, there's 5 of them. Well, there's actually 6 of them we talked about. We're not going to cover horizontal stretches and shrinks. So we've got vertical and horizontal translation. Remember, that's back and forth, up and down. We've got reflections over the x-axis and the y-axis. And then we're going to cover vertical stretches and shrinks, but not horizontal stretches and shrinks, just vertical ones. All right. So first of all, vertical translations, we saw the graphs of them in the last chapter, but when we're talking about looking at their equation, it looks like this: f of x plus k. All right? And this is just a picture. I know it's kind of complicated, all this stuff, but what I wanted to show you was that things moved either up or down. So this is vertical translations, okay? All right. Next, let's look at an example. All right, so write a function g whose graph is a translation 3 units down of this graph. Well, what I need to remember is that f of x plus k is the transmogrifier, like in Calvin and Hobbes. This is the thing that's going to transform this. And it's going 3 units down. So k equals -3. All right? So I'm going to take f of x. F of x is 2x plus 1, plus k, which is -3. So I have 2x, 1 plus -3 is -2. And because I transformed it, I put it into like this little transformer machine, I have to give it a different name. Okay, so g of x is 2x minus 2. All right, I have one for you to try, and then we will look at that. Oh, this is what it looks like, sorry. This was the original. This is the line, and this is it moved over. Or I'm sorry, moved down. I mean, it kind of moves over too, but this one is moved down. Okay, so I want you to try this one, and we will cover that in the next video.